So I'm going into the Rubble Mound folder, and then there is another set of files here that we'll work with. So under Start Files, we have the project we can load in. And this is a big case. So this is a real-world case, something we used in a reimbursable project. So it's not really optimized to run quickly for purposes of a webinar or a workshop. So I'm not really going to go into actually running this, but I will show you kind of how that's done just like I just did. So when it comes in, we have our base bathymetry here, and by default it comes in with a big range here. So if we wanted to, we can change this contour range so that we can see a little bit clearer what area, what we're working with. So I'm going to change this minimum to -5, and then the maximum to 20 to really expose the areas that we're working with. And just click OK here. And so you see the higher elevations, but then once it's done, you should be able to see closer in. Is it working? It must still be processing real quick. Okay. All right, like I said, it's a big file, and so it takes a lot of processing power. So anyway, this is the area that we're working with. We have long breakwater here and one on the east side, sheltering this harbor in the background. And this particular case, we had degrading breakwater on this side. It was letting some current flow through there. It was bringing in sediment and filling up this channel. And so we wanted to examine this and do a couple of test cases. And so that's what we did. And so from this, the next steps for a Rubble Mound jetty would be to define where that jetty location is that we're going to specify as Rubble Mound so that we can assign data sets. And so we do that through the map module, and I'll just create a new coverage here, and I'll call this Rubble Mound structure. It doesn't matter what type. And so with that selected, I can go in and choose the area that I want to use for my Rubble Mound. All right, once I close it in on itself, you can see it automatically selects that polygon or the arc. It's not quite a polygon yet. Then you can go under Feature Objects, Build Polygons, and then select it. And so that's the polygon that we're going to use for this. If you want to use one that's already created for you, I've placed this rmtest.map file in the other needed files directory, so you can pull it in and use the same one that we're going to use. And I'll go ahead and do that now. So I'll delete this one out, and then I'll pull that other file in so that we have the same file that we're working with. All right, I'll build the polygons. And then the next thing we need to do is to create those data sets. So I'll go back to the quad tree grid, because this is where those data sets are going to be, and choose Data, Data Set Toolbox, Data Calculator, and then I'm going to give a default value of 0 or 0.0, it doesn't matter. It's always going to be a float. And then a name for these different data sets. And so I'll just go through and create this several times. And you see, as I'm working on this, each one of these data sets is being added to the list. And so I've got one for the ID, the rock diameter, the base depth, the porosity, and the method. And then I can click done, and they're all showing up over here in the data tree. So now I need to find a way to give a value for inside this polygon for my rubble mound. And so that's done by selecting the polygon, going under feature objects, selecting the data inside the quad tree grid, and it selects the corresponding cells here. And then I can go to each one of these data sets and specify value. So those cells stay selected regardless of which data set I'm choosing. So I'm starting off with the ID, and I'll make the values for that 1. And you'll see that your screen changes to acknowledge that you have changed the range of values. And so we'll do the same thing for rock diameter. And I believe the value that we have for that is 1.5 meters. Change the base depth to 2. The porosity is going to be 0.2. And the method that we're choosing today is the most recent method done in 2007, and that is method 1. All right, and now all of these data sets are created. The values for these data sets are assigned, and you see that they're all for this area that we selected for our Rubble Mound jetty. All right, and so at this point you would normally just go through and save your project, and I'll go ahead and save this in the same directory as I did your start files here. And then we can go in and I'll show you that now being added to this test data sets, instead of just a D50 hard bottom and Manning's in, we're also going to have values or files for the ID, method, porosity, rock diameter, and base depth. So all of those are written to that folder. And so these are the files that we're going to have to either move to the CMS flow directory or reference in the advanced cards to this particular relative path. So either way, it's easier for me to just copy the files, but I understand sometimes if you're running out of disk space, you don't want to make too many copies of things. So whatever you want to do is fine. So, but before we can do that, we need to make sure that our model control is set up correctly. Everything else is done appropriately. So I'm just going to change this a little bit. Running with 4 threads. We have our Manning specified. Sediment transport is on, and all of our values are set. These are things that you would have already set up. I have my hard bottom set. I have the output and other options already set. If you wanted to see some other things, you can turn those on. And then make sure you go through and save the project. Again, I was about to save, export, and launch, but I need to create that advanced cards file. So what I need to do is, once it's saved, I need to export the files. And so it'll create a new directory for my simulation here, which is there. And this folder is always the same name as your project. So DanaPoint_RM_test. And then inside of that, we have for CMS flow, And then in there is the name of the simulation. So if you have multiple simulations, then you have multiple folders here. Okay? And so what we need to do, it's still working, but we can go ahead and copy these files over. So I'm just going to copy those, go up one directory, and then drop them in here. All right, and then we can create that file, which is basically just a text file. So we're going to call it advanced.cmcards. And I'm going to cheat a little bit and figure out what the information is that I need to write into that file. All right, and so I'm just going to basically copy the same information as I'm already given here. And these examples are also located in the CHETN as far as what goes in the block and what the names of these cards are, things like that. What I'm adding is a little bit more information about what everything means and how to, manipulate the files a little bit. So let's keep going here. If my fingers would work. And if I'm spelling everything right, then everything should work without a hitch. All right, and the spacing as I show it over here really isn't needed, but you just need to know what the file names are. And if I look back in this folder, I can get that file name here, and I'm just going to specify it. And then, as I mentioned earlier, you just need to make sure that you have datasets / and then the end part of the name here, this dataset name that's in your data tree. So datasets / ID. All right, and if I look, that's what it shows here. And I just do a similar thing for the other ones. So it's a little bit of a pain to do all this hand editing, and that's why we are changing this a little bit in the coming version. It's just too much trouble. I almost messed up there. .h5 to do all this by hand. And the last one. All right, and you could, as I did on the first one, just cut and paste these names here instead of just hand typing them. And that at least you would be assured that you didn't make a typo or anything like that. So, but I think I have everything done correctly here. I'm going to go ahead and save this advanced cards file. And you notice it's here. It was just updated. I'll edit it and just look at it just to make sure it looks fine. So let's go ahead and try to run just real quick. If you needed to switch to a different version of the executable, you could do it just like we did before. But since we just did that, and I think it should be good, we're going to just go ahead and launch, and hopefully everything works out correctly. All right, and so one of the things I should have changed, and I saw this earlier, is that we started out with the time step of 600 seconds, and it's evidently too large of a time step, so it wants to recalculate down to 300. And so I'm going to go ahead and abort this, make that change, and then resave. Otherwise, what will happen is that after 5 or 6 different iterations at 300 seconds, CMS will pop right back up to the 600 seconds, realize that it needs to lower it again, and so you're wasting extra computation time throughout the run. So let's just go ahead and change this in the first place to 300 seconds. And that time, since the advanced card is already written out, I just chose to save, export, and launch all at the same time. And so hopefully it will work correctly this time. So as I said, it's a relatively large file, and so it takes a little bit to write everything out, and now it's running. And I can switch down here. And we see that it's going to be running now. So this is probably going to take 3 or 4 hours. This is a relatively short duration that I specified here, only 120 hours or so. And so it may take a while, so we're not going to sit through this. And I'm not really going to go over the visualization at this point, but just know that when it's done, you have these different solutions for water surface elevation and velocity, morphology change, and transport rates that you can visualize and make any adjustments as you need to. But that is pretty much it. Are there any questions? I see a couple of things over here. Oh, and that's actually something that I wanted to bring up. The structure types that we're covering today are only the flow model structures that really have not been implemented in SMS. We're not covering the various CMS wave structure types. And there are a couple different ones. There are some publications on those. To where you can make sure that everything is set up correctly, and it explains how to work with those structures. But it wasn't something that we thought of to actually cover as far as this presentation. It might be something that on Friday, Friday is set aside for only questions about stuff we've covered or anything that we haven't covered. And so maybe I'll go ahead and try to put something together to cover CMS wave structures and a couple of the various things to cover for a short time period on Friday, if that's okay. Are there any other questions that we haven't addressed, either about this or the weirs or other types of structures? The other structures I'm not really covering because they're pretty much the same kind of setup as we're doing in this. They're a little bit different, but as far as setting parameters and writing to an advanced card file, or setting up data sets, things like that. All of that is pretty much the same for all of these. Once we get the new interface in 13.1, we will cover this again. I'll probably put out either an updated CHETN or a short video clip on each one, covering how to run those and the changes as far as those are concerned. But these different, the culvert and the tide gate, those tech notes are available, and they have a lot of information, example cases, and if you need or want to run with one of those types and are having trouble, just give us a call and ask us, either through a call or email, and we'll try to help you with that as we can. So there are a lot of different options like this on a culvert. There's a radius, a width, different types, coefficients, and so it's done just a little bit differently. There's a lot more parameters, but the overall things that you need to do within SMS are relatively the same. As far as setting these files up and the relationship, the number of cells, things like that. So tomorrow Hong Hai will be presenting, and tomorrow's webinar will be on multiple sediment grain sizes and getting that set up, explaining the differences in size classes and bed layers and output and things like that. And so if you want to work with those, hopefully we'll see you there tomorrow. The presentation for that is already available on the website, as well as the data. And so if you want to go ahead and download that and maybe look around a little bit, and if you have any questions or whatever, feel free to chime in and ask.